Good afternoon. This is Dr. John Bennett broadcasting from sunny Miami. We have another in the series of Medgadget Hangout channel, Hangouts, and we have the pleasure today of having Stephen LaBouef MD from Louisiana. He's going to talk about wearables, the wearable industry, and how he exactly what he does putting wearables on the ear. And we also are joined with the head editor of Medgadget.com. Hello, Gene. Well, first we'll start with Gene. We'll introduce him. Hi, Gene.
Hi, guys. Thanks, Stephen, for coming. I'm the editor of Medgadget, and I hope we have a great discussion.
Very good. Welcome, Gene. And Stephen, could you first well, introduce yourself first.
Oh, you bet. So my name is Dr. Stephen LaBouef, and I'm one of the founders and the president of Valencell. And as many of you may know, Valencell is a technology development and licensing company in the wearable biometric space. So we don't make consumer products. We power those products with accurate biometrics that they use to generate health and fitness assessments in their products.
Very good. Stephen, I was going over your background. You have a very interesting background. Can you start at kind of at the beginning, including your background with NASA and animation?
Oh, yeah, you bet. So, you know, I've been a freelance cartoonist since I was actually in 9th grade. So I sold my first cartoon to Dairy Goat Journal. That's right, Sheep and Dairy Goat Journal. I'll never forget that, because most of my cartoons dealt around animals at the time. And then I got into animation, and then also into movie making, but not porns, just regular movie. And then my educational background is in solid-state physics, and I got a job straight out of my PhD program at General Electric and started working in their solid-state device group, developing new solid-state devices. But what I learned was that GE was much more interested in what you can do with those devices rather than the devices themselves. So I started designing systems and sensor systems. And it got to the point where I was developing biosensor systems. And then I just kind of got tired of working for the man every night and day. GE is a great company, but I wanted to start my own. And that's when I left out to form Valencell.
Mm-hmm. Well, when did you first develop affinity for computers?
For computers?
Yes.
Well, probably, you know, so first of all, you know, I'm from the swamp. I'm from 50 miles southwest of New Orleans, so there weren't that many computers where I was from. And I had a crazy uncle, I'm not going to say his name, but he was big into computers, and he kind of got me into them.
Mm-hmm. Okay, and Gina, you can ask questions as we go along if you want. And I'll ask questions, and you can ask more as we go along. Can you go through your science career briefly up to this point?
Oh, you bet. So, you know, I have my background is in solid-state physics, biomedical sensor technology, and then also a strong background in device and electronics engineering. And a lot of the research we do today at Valencell focuses on how we pull accurate sensor readings from the body into devices that people already wear. Because one of the biggest challenges in the new wearable space is that you have to take this old medical technology that works great when people are lying down in a bed. You have to make that work just as well in someone's wrist device or their earbud or whatever the case may be. And so a lot of our research now focuses on validating technology for wearable use cases so that it is clinically and medically relevant. For example, one of the projects we have going on right now is some blood pressure sensing technology. And the technology is designed to be able to tell you whether or not you are potentially hypertensive or not. So we're trying to differentiate those two groups. And it's challenging because the technology has got to work on a wearable device, not a sophisticated piece of medical equipment.
Stephen, can you talk a bit about the sensors that you have that you're using, and particularly like Valencell's inner ear or in-ear technology?
We started in the ear back in 2006, And the reason we started in the ear was because we wanted to find one place on the body where we can measure a number of important things non-invasively that was in something that people already wore. And there's the two best places on the body for monitoring as much as possible are the ear and the rear. And we kind of wanted to stay from the rear. But on the ear, you can get the tympanic temperature. You can assess blood pressure. You have this in the ear between the antitragus and concha of the ear. You have this bank of arterioles that just pulsate with blood, and you get access to that pulsatile blood waveform. You get accurate heart rate, respiration rate. You can assess very accurately at the ear also blood oxygen and different constituents of blood analyte, different types of hemoglobin. And you can do this all non-invasively. Another thing you can do at the ear, which you can't do in other parts of the body, including the rear, you can't even do this, is auscultatory analysis, where you look at sounds from the body. The ear is kind of a natural amplification, sound amplification tube, and so with the ear device you can pick up these sounds from mastication, so determining maybe what people are eating or swallowing. You can sense, for example, if you're trying to say assess someone's sleep quality, you can assess snoring, for example, there readily at the ear. You can pick up breathing volume sounds and differentiate those from cardiac sounds. When you then try and apply that to a consumer device, which most of our customers are doing consumer devices, the problem is the processing for audio is pretty high. And so people have tended to stay away from that, and they prefer to use photoplasmography. So most of the products in the market, actually all of the products in the marketplace today using valence cells technology are based off photoplasmography, or PPG, which, as many of you may know, is a way that you can see volumetric changes in the body with light. And that's why we're able to do this non-invasively. However, the big challenge with photoplasmography has been three things. One, getting the electronics small enough to fit in the device that people wear. Two is the motion artifacts. The motion artifacts are so extreme. Light bounces off everything. But when you're trying to see this small blood flow waveform in the midst of all this motion noise, it is extremely difficult, especially on the wrist. And then the third thing is environmental noise. Because you're using a light to see what's going on in the body, the sunlight is so strong, it overpowers that tiny sensor and that tiny bit of light you're sending in the body. And in hospitals, most people don't know that most pulse oximeters that are used in hospitals, those little finger clips that go and measure your blood oxygen and heart rate, those pulse oximeters don't work outdoors. And the reason they don't is they don't have to. They're used in hospitals. But we had to make our technology work outdoors because people run with our technology outdoors. And so we had to develop a new way to even remove the sunlight, which is different than what the hospitals had to use because they never really had to deal with that problem.
You know, MIT is doing some work with slow-mo photography, measuring the pulse rate. Have you heard of that? I suppose that has something to do with optics too, where they can actually measure the pulse rate, taking slow-mo pictures of an infant's face.
That's I love that technology.
Yeah. Is that photo?
I love the technology. I'm sorry, I think I'm talking over you.
I'm sorry, is that photo-optic technology? Is that considered photo-optic?
It is. And the way that technology works is exactly like you said. The concept is you look into a mirror, and you have a camera looking at you, and frame by frame you're able to analyze differences in the color ratios and the intensity ratios, and you can analyze that to determine the person's pulse rate, even the perfusion, so how profuse is their skin, respiration rate, and potentially some other things as well. The limitation of that technology is it's not wearable, and you can't measure in real time while people are moving because it's difficult when people move. Like when I'm doing this right now, the camera it sees what it sees what it thinks is a perfusion change, but it's not. It's shadow changes. But for the use case of waking up in the morning and taking a snapshot of yourself for say 30 seconds, doing analysis, that's a great use case in front of a mirror.
Yeah, I think they use it in sleeping infants that are not moving, obviously.
Stephen, can you talk a bit about how you measure blood pressure from the ear?
Yes, I can tell you some things about it. Not everything, because some of it's proprietary, but the bulk of it, frankly, you can see in one of our patent publications. What it is that when people of course, blood pressure is monitored primarily today non-invasively with a cuff. And only problem with the cuff in the consumer use case is that people don't like to have to put a cuff on and have it squeeze and relax. And so there's been a big push to try and be able to do measure blood pressure accurately enough for some kind of hypertension identification. Accurately enough without a cuff. And I didn't mean for that to rhyme this time. Oh, God, I didn't mean for that to rhyme either. But you want to be accurate enough without a cuff. And there's challenges there because what that means is that you can't measure the pressure directly. You have to measure it indirectly. And I'll give you an example. One of the technologies that's used, and we don't use this, but I think I should mention this technology because it is a good one. Transit time. Sensor at two disparate parts of the body. One might be a finger, one might be at the top of the head, it could be elsewhere. And you look for the time it takes a pulse wave to go from one part of the body to the other. And from there you can deduce what the pressure probably was in order for you to get that particular speed. And we do not use that approach, and the reason we don't is we wanted an approach where it was just one location on the body, so it's fit in well with the wrist devices and ear devices and other form factors that people already wear in the consumer space. And so what we do is we look at the photoplethysmograms. So we do it completely with the photoplethysmograms. We've learned how to characterize the photoplethysmograms in such a way that we can pull off the blood pressure information. So it's a very different approach than pulse transit time. Pulse transit time uses two measurement locations and tries to infer a time difference and measure a time difference and infer a pressure. In our case, we infer the pressure from the optical waveform itself.
Steve, when you say ear sensors, do you mean internal ear or external on the lobe?
Oh, great question, John. In our case, there's two techniques we've used. One is in-ear, where you actually would interrogate the tympanic membrane, or the ear canal. The other is external ear. For the consumer devices, we found that we get a lot better results with the external ear. And here's why. Well, there's a bunch of reasons why, but one of the big reasons why is it turns out there's a lot of variation in the human ear canal. And so when you're trying to make a consumer device that's got to apply to a broad population set, you can't get that optical sensor to couple well in everybody's ear. A medical doctor could go in there and rig it up to where it would work, but the thing is they're expensive to have in every consumer Best Buy. So the problem is getting the ear canal to be uniform was more challenging. So what we found was that it's much better to use the region between the antitragus and concha of the ear. Now there's another benefit to that too, and that is usually when people wear an earpiece, they also want to listen to music or have some audio experience. And when you have the sensor in the ear canal, it interferes with the audio response. And then the third reason is because it turns out that you can get a really nice signal in this region of the ear that the noise. To give you an example, if you ever I don't know if you've ever been on a plane or whatever, want to stop, put your fingers in your ears and not hear what's going on outdoors, if you move your mouth like this, you notice there's an incredible amount of motion artifacts in the ear canal. So one of the things we noticed is it was hard to accurately measure people when they were talking when the sensors were deeper in the ear canal.
It seems like the science of optics is a big thing to know if you need to understand your sensors. Basic optics.
Yeah, I was wondering, do you integrate other sensors as opposed to just optical sensors?
Good question. We do. Well, all of the consumer products that use technology today use optical sensors and inertial sensors. And the inertial sensors are used for two things, at least two things. One is two activity contacts, and I'll explain that in a bit. The other is to help remove the noise from the optical signals so that you get a cleaner signal. You see that the noise is so profound, you look for a way to remove it in real time. And by using an inertial sensor against the optical sensor, you can clean up that signal. But also the inertial sensors give you contextual information. And what I mean is, For example, if you, let's say that you're running at a steady pace and you increase your speed, and then you go back down to a steady pace, a lower pace, we can see, because we can measure your activity and your body's response to that activity in terms of heart rate and respiration rate optically, we can see your heart rate response, we can see your heart rate recovery, we can see your cardiac efficiency, all autonomously, because we're looking at not just the signal from the body, the biometric signal, but we're also looking at the activity signal. Now, we've also explored a variety of other sensors. I told you about auscultatory sensors or body sound sensors. I told you, well, I didn't mention, I don't think, about tympanic temperature sensing maybe, but I don't believe I also mentioned about bioimpedance sensing. Now, the reason why we have not launched products yet in the consumer space that use tympanic sensing or skull sensing or bioimpedance is because those technologies still have some challenges. And if you like, I could explain what some of those are, but you know, I don't want to go on a diatribe unless that turns you on.
But can't you gather a single lead EKG at least from the ears?
You know, you can, but here's the caveat. The ECG works best when you have a large spacing between 2 points of the body, because you want to measure a difference in potential. One of the limitations of the ear is the difference in potential from here to here, or different spots of the ear, is quite small, and it's so small that the signal to noise is even much smaller than the optical signal to noise. And so we haven't found a good way to measure heart rate with ECG in the ear, even when somebody's exercising. We can when they're at rest, but not when they're exercising. Because that ECG signal here is so weak compared to the throw or the spacing here on the chest, where you have a higher potential drop.
But between the two ears.
It's a good point. The problem is that, let's see if I could, I wish I had a drawing board, I could explain it better. But what it is that the potential field across the body, it goes kind of along this way. And so it turns out the potential drop across here and here is not much, because they're at almost the same potential.
That makes sense.
Well, I keep going to the science of optics. A quick story. I hadn't seen a friend of mine for a long time. He moved to South Dakota, of all places. And I said, "What are you doing?" He said, "I just wrote a book called Optics for Dummies." It was really bizarre. And so he said to me, "John, I'll send you a book to read." I couldn't get past the first chapter.
Well, you know, John, you were talking about the importance of optics in this case. In general, what I found is that in the field of wearable biometrics, there's two disciplines that need to merge. Sometimes companies lack one, if not both of these, and one of them is the understanding the raw sensor technology, what it can do. If you're for example Jawbone does a lot on bioimpedance. They need experts who understand impedance really well. But the other thing you need is people who understand physiological models. In other words, what's really going on inside the body. And what we find is that companies founded by engineers oftentimes tend to be really good on this side, good on the sensor side and the sensor fundamental side, but they tend to not understand the biological models very well, and vice versa. And so getting those teams together to generate a really interesting use case based off the sensor technology has not been as seamless as I would have liked to have seen it over the past few years.
Have you got into applying algorithm to your data that your sensors generate, or that's the next stage?
Oh yes, so there's two layers of algorithm employed now, John. One of them is how we remove the noise from the biometric signal so we can get accurate heart rate and respiration rate and VO2 and blood pressure, these types of metrics. That's one level. The second level is what do you do with all those biometrics to generate an assessment, some kind of physiological assessment. For example, taking heart rate information, respiration rate information, and activity information, combining that into a model into max. Or observing what exercises somebody's doing with the inertial sensors, the accelerometers, for example, to get a motion reference. understanding what the activity context is, and also, you know, measuring the biometrics to be able to say what activities are making you fitter and what activities maybe for you are actually making you less fit. So being able to do some of these broader type of analyses. One of the projects that's going on right now by some researchers is taking biometric data collected by people wearing heart rate monitors and activity monitors and taking food diary information and trying to do a correlation between what foods are maybe improving someone's health. You know, over a period of time, doing these types of analyses.
Do you think there'll be a long time before, like, medication release is tied to interpretation of the data? Do you know what I'm saying? It interprets data,
yes,
and the body says, well, release this medicine. Has there been much work in that area? Do you know?
It will be a few more years out, but I tell you right now, what we're seeing is, I guess it. I was about to say you'll never believe who are the leaders in this forefront, but now I'm thinking about it, I guess it is kind of obvious in some ways. The groups that are leading this part of it are actually the CROs, the contract research organizations. What they're doing is they have customers who often are drug companies who are trying to understand how people are using, in research studies, trying to understand how people are using the drugs and also how the drugs are affecting their health. And so what these guys are doing are they're buying these biometric monitors and having people wear them during the course of the study, during the intervention. And so what's happening is now these models are being developed that correlate, you know, the intervention with the outcome. And so I do believe you're going to see this being adopted in medicine as it grows out of what it is doing, where it is today, which is in the clinical research area.
We do have an example of drugs being released. You know, the artificial pancreas now, like Medtronic has, you know, glucometer and a pump that are connected wirelessly to each other, and that delivers insulin, you know, according to a certain graph that it follows. So we're, you know, that's a great start.
That's a great example, and it reminds me of another example similar to it, I guess, which is a quasi-non-invasive technology, and I can't remember the name of the company. You might remember it, but they do a timed release of nicotine based off of your time of day. And what they found is that, and I can't remember now if they do a custom circadian analysis to decide when it's best for you, but what they discovered was that in their research is that people were more likely to quit smoking if they had nicotine for the day, and so they introduce it on, you know, a cycle depending on your circadian rhythm, as I recall. And I can't remember the name of the company; it escapes me. It may come to me in a bit, but I thought that was an interesting. Oh, you know, maybe it's Chronotherapeutics. Is that the name? Chronotherapeutics.
It doesn't. Oh, sorry.
I believe. Yeah, I believe.
Yeah.
But Medgadget is doing a lot in this space. You know, one of the things they're also working on is a heart rate sensor that's embedded, and it is embedded and it is invasive, but it is so small and so relatively non-invasive that I can see a time, maybe, you know, certainly not 5 years, probably not 10, more likely 20 years out, where people are not afraid to have these implantables for the purpose of monitoring, because you never have to worry about wearing anything new. It's there, and it's getting all information right there from inside your body.
Right. Steve, can you talk about any of the companies that use your product, that any of the products that use your technology?
Oh, so some companies have forbidden us to mention our relationships, and vice versa. In some cases, we've forbidden companies to mention relationships with us. But there are companies that we can talk publicly about. For example, some of our licensees are Sony, LG, Jabra, Scosche. There are some really extremely innovative startup companies, such as Atlas Wearables and Caden, who are licensing our technology for their products in the sports and also the jewelry accessory side of the marketplace. Also, Intel and SMS Audio use our technology in the BioSport earbuds. for the heart rate monitoring, where it works by the SMS audio, the BioSport headset. You plug it into the phone, and the music comes from the plug, and also the data goes through the audio jack, so that you don't have to have Bluetooth or anything like that. So a number of different companies. Most of them are earbuds, some of them are wrist, and some of them are armband. Scosche, for example, they have a product that is all it is, and all it focuses on, is a chest strap replacement. They found that people were much more likely, much more willing to put a band around their arm than around the chest if they had heart rate monitoring that was just as accurate. And so we were able to provide that to them, and they turned that into a band around the arm that people use in sports, but also in clinical research. In the clinical research case, you wear the band throughout the day, and the band collects data, biometric data and activity data for post-analysis.
Steve, any work at all on the non-invasive detection of serum glucose?
I know a lot about this area. When I worked for GE, part of the technology I was working on was investigating that area. Outside of GE, when I started Valence Cell, I did a reinvestigation. And I'll say a strong statement first, and then I'll explain it. There will literally be stem cell regenerated pancreas solutions to non-invasive glucose monitoring, or rather diabetes care,
right,
before there is any non-invasive medical grade glucometer out there. And the reason is because Gene, I'm sorry, what did you say?
Killing all our hopes here.
Yeah, that would be a killer app, man. That would killer app.
John, you're right, and Gene, you're right, but to me, it's much better to have a cure for diabetes than to have a non-invasive wearable about it. And two, the problem is there is science behind. There are some companies working on subcutaneous sensors that go below the skin. Yeah. There is science to show that can work.
Right.
But there are also companies that claim that they can do this non-invasively, completely, outside the body. And there's simply no evidence that you can measure glucose good enough to control the body. And there's a great, I tell you, don't take my word for it. What I encourage you to do, a former CTO of Johnson & Johnson, his name is John Smith. He wrote a great paper. You can download it. He finished his career. He spent so much time and energy on non-invasive glucose. He in his retirement, I believe in his retirement, he wrote this paper on. It's called something like "Chasing the Deceitful Turkey" or something like this, which is about non-invasive glucose monitoring and all the methods that were used and why they didn't work, and why he is still an optimist that one day someone will solve the problem. But you see everything everyone's tried, and what's funny, these are things people tried 30 years ago, and people are trying the same things now, and there's just never been any science that they can work. A classic example is, do you remember the Gluco watch?
Yeah.
Yeah. The Gluco watch, the way it worked was it used a technology called iontophoresis, and it was the first, to the best of my knowledge, it was the first FDA-approved non-invasive glucose monitor. And it was a watch that used iontophoresis to pull ions from the body, from the upper layer of the skin that contained glucose. And then they had some sensors with enzymes that pulled in. When they pulled in those glucose ions there, it was able to then deduce what your blood glucose was. Mm-hmm. And the FDA approved it. It was an FDA-approved device. However, it was recalled. And it was recalled for two reasons. One of them was it was burning holes in people's hands, okay. And that's not good. You know, diabetics oftentimes already have troubles with sores. You don't want to cause new ones. The second thing is that there's no strong correlation between blood glucose and skin glucose. And so if you want to use the glucometer to control your insulin dosage, it's so off that it really doesn't have that utility. Yeah. So what I'm really bullish about stem cell research in this area, and also subcutaneous sensors. I do believe in that.
What about contact lenses?
Contact lenses are interesting. You know,
Google's working on
Google announced a relationship with who is it with? Y'all recall?
Bosch Loam. Geez, I don't know.
Yeah, it wasn't Bosch and Loam. Maybe it'll come to us. Was it Roche? Was it Google and Roche? Well, Anyway,
I'll look it up. I'll look it up. You guys keep chatting. Look it up.
With a company that has been focused on the glucose monitor. What Google did is they said they're working on a contact lens that can pull glucose from tears and then do an assessment of glucose. Now, I'll tell you what I know about that technology, because it's not it's something that's been discussed for decades. It's not a new concept. Glucose is in tears. However, there's a big debate about how it correlates with blood glucose, which is what you really want to measure. So that's the first problem. The second problem is, just because there is a sensor for measuring glucose doesn't mean that it's something that you can wear all the time. One of the limitations, and this was a problem with the GlucoWatch also, is that these glucose sensors, they end up having to be refreshed or replaced because they degrade. And so one thing I have to think of is, okay, I got to be able to measure blood glucose, which is not the same as tear glucose, but also I've got to be able to not have to be so annoying as to have to keep replacing the contacts nonstop all the time. And yeah, does it say, was it Novartis you were working with?
Yeah, Novartis.
Oh, yes. Okay. And what I tell you what I do like, though, so I'm not bullish about glucose in contact lenses, but I tell you what I am bullish about. I think smart contact lenses could be phenomenal. Imagine contact lenses, right, that allowed you to essentially have kind of superhuman vision. That's viable, and I think that there's a bigger market for using contact lenses to allow you to have an interface you can see digitally and to have enhanced vision than there is to do an assessment of glucose to provide insulin control based off of tear-based glucose. So I applaud the research. I don't discourage them for going in that route. I think they're going to have more interesting results from having smart contact lenses than they will for controlling glucose. But again, you know, research, I think in Northwestern University, they've shown that they can turn stem cells into beta cells, and that they work in 30% of the people that they tested. Not only that, they've shown in a recent study that they understand why it only works in 1/3 of the population and not the other 2/3. So I think diabetics, if I'm not diabetic myself, if I were, I would be super excited about a possibility of a cure within, a real cure within maybe even the next 15 years.
You know, in Miami, they just did that. They implanted the stem cells in a diabetic female, and it's working so far. It was just reported, I think, a couple of weeks ago.
Yeah. I remember when I was at GE, GE talked about how they were going to start moving into the space of regenerative medicine. They didn't know how, but they were going to move in that direction. And I recall that the size estimate of the regenerative medicine market at the time, and this was back in 2006, was $3 trillion. Like basically, there were 3 opportunities just for regenerative medicine. Now that's only going to grow. So I think, you know, all of the technologies designed around helping people as they age, perform better, live healthier, and also essentially cure these diseases. I'm really bullish on that. I'm really excited by that.
You know, that's why I like Hangouts, Steve, because we'll be able to interact with scientists in stem cell, genomics, very easily. You know, where it's hard to do that when you walk up to someone in the hospital or something. But in Hangouts, you can do that.
You know what's funny, John? In solid state, you know, my background, over the decades into the 80s and 90s is when they started realizing they needed to provide people development kits to build things with. Mm-hmm. And when they provided people with those development kits, the market just exploded. People thought of ways to use it. I predict that within 20, 25 years, there will be stem cell development kits where literally engineers, biomedical engineers, will be able to take these development kits and try experiments with these stem cells to generate all kinds of interesting outcomes. You
know, the combination of stem cell and 3D printing, there are some places that can actually 3D print stem cells. So you can have almost an unlimited supply of stem cells. Those two industries growing and converging, it's going to create a lot of wondrous things, I think.
Yeah, oh, absolutely. I mean, it's really the innovation is happening at such a rapid pace. The FDA is struggling with how to allow it to be used. I give one example. When I was in grad school, back in the 90s, I remember about a company developing a biotechnology to essentially cure leukemia, by modifying the genes in the body. And I thought that was the coolest thing, and I started researching it. I tried to invest in the company, but I wasn't able to invest in the company at the time. They have literally saved the life of my good childhood friend's daughter. And so what they've done is they've genetically modified her cells to attack the cancer cells, and then genetically modified her cells to make to not be affected by the cells that were attacking the cancer. And when they did all this together, she's actually completely cured of cancer now. And that was, but the only reason that was allowed is the FDA said they changed the way they did things. They've allowed now people to opt in, as you know, to being able to be test participants in these kind of crazy cases where you're going to die otherwise, and that's allowed for a lot more innovation than we had, say, 15 years ago.
This talk is so interesting. Gene, I haven't even been watching the question board, and I neglected to mention that we have a question board. But before the next hang, I'll make sure I mention that. Okay. Because Gene and I are trying to get this tech going, Steve, so that when people can actually watch this and can ask questions. But we'll get better at it. We'll get so. Anyways,
did anyone send any questions by email or anything like that I should address?
Not yet. Have you any questions, Gene?
No, I'm good, thank you. I think.
Yeah, I think we could go in a lot of areas with you, Steve. Man, you're really into stem cells, man.
Yeah, it's funny. I mean, it's not even my core discipline, but in the marketplace, I have a very broad understanding of what's going on in the marketplace, and I have to, because I have to see how my company needs to grow and how it needs to address needs in the marketplace. But I'm very excited about the marketplace. I think technologies that combine my old discipline of what I was brought into, which is solid state, with biomedical science, those really interest me. And there's many different categories. Wearable devices, what's great about those is they're we found ways to make these affordable, easy-to-wear devices that can have a real big public impact. And we get to see it before you get to see it, because we license the technology out, so we know what our licensees are going to be launching, in the next few years. And so we get to see how they're using this data to actually have real positive health outcomes in ways that consumers can't really see right now. And so we get to see that ball rolling in that direction, and it's going to be big things.
Well, Gene and I were talking about that before the show, is that the accessibility of devices now, it's getting more and more accessible to the public. And Gene mentioned Verizon, and I mentioned Amazon. I think that soon you can buy a lot of sensors on Amazon. If Amazon doesn't already have a wearable, I don't think they have a wearable store, but I think eventually they will.
Yeah, yeah, that's pretty perceptive. I bet they will, because right now Amazon, some devices, they sell a whole bunch of the devices. They sell all the chest straps, all the activity trackers. Almost all of our partners' products are sold on Amazon. And part of the challenge is they have to find a way to educate consumers about which devices they should buy and what they're going to do for them. And the industry actually still hasn't done that well. Consumers still are confused when they go to buy these trackers.
Yeah. Well, with the internet you can investigate, but certainly in the old days, to buy a medical device, you had to go to. The public wouldn't have access to it. You had to go to specialty stores that were made in some faraway factory. But now they're a lot more accessible, and information is more accessible too, when you can just research on the internet. Doesn't guarantee the veracity of our investigation, but it gives you options to look into something.
One of the big challenges for consumers right now, and we're starting to see complaints online by consumers, and also we're hearing it in the streets, is that one of the problems with the sensors out there today is they're not very accurate, a lot of them, in you garbage in and garbage out. So, you know, a consumer might buy something they think is a sleep tracker, and they'll say, well, you know, it says I've had great sleep, but I know my sleep actually kind of sucked. So it's just not making any sense. And then in the case where it does track them, and it says their sleep is very bad, they say, well, then now what? Now what do I do? And there's no recommendation to give them about what they can do uniquely to them in order to improve their sleep.
You have the data, but what to do with it?
Yeah, the best I've seen people, probably Jawbone is one of the companies that at least ostensibly is trying to do this with the most fervent interest. For example, in some of their products, if you wear some of their activity trackers, when you go to bed at night, when you turn it in sleep mode, it'll communicate with your Nest temperature controller and then drop the temperature in the room down. And so one of the things you can do is you can start to learn what temperatures in environmental conditions help you sleep the best, and then, you know, the system eventually modulates your temperature at night based off the best that's for your sleep. And this kind of thing is new, and, you know, Jawbone is at the tip of the iceberg in this area, but you can expect to see many more things like this as you move forward. For example, like I mentioned, if you're using a food diary, an identification of which foods you might actually be allergic to based off what the device has learned about you and your food diary that you might have not learned otherwise, you know.
Well, okay, very good, Stephen. We could go on. Interesting guy. Gene, any comments?
No, thank you for coming, Stephen. It was fascinating, this discussion about it.
Yeah, man, you're interesting as hell.
I'm happy to come back again if y'all let me on. Thanks for y'all time.
Well, yeah, sure. Any new developments, and people can get a hold of you through valencell.com, right?
Oh, yes.
Okay, let me just quickly show that website. Screen share. Hold on. Valencell. Do you want to give your email address, Steve, or just get it through the website?
It's best just to go to the website, but I tell you, my email address is just my last name, LaBouef at valencell.com, so it's very easy to remember.
Well, your spelling of your name is difficult. I wrestled with it for like a week. It's LaBouef. Steve LaBouef.
Well, no, I'll spell it. It's L-E as in Edward, capital B-O-E-U-F. It's LeBouef as in the beef in French.
Okay, very good. Okay, thank you for coming out, Gene, and of course, thank you, Stephen. And we'll see you soon.
Right,
thank you, guys. Nice talking.
Yeah, hang on. We'll just chat a second. Let me just stop this.